Hello, Rashbir.
Hi, Mikhail.
How are you?
I'm good, thanks. How are you?
Fine, fine. Another
Great.
webinar again. Let's see if we are online
Yeah.
this time without any issues. Can
Mm,
you check if everything
Yeah.
looks good?
I'm checking. I'm on the
Yep.
webinar page. It says starting soon.
Okay.
So maybe let's wait a couple of seconds.
Mhm. This time it actually says you are live. So
Oh, great. Now
hopefully.
I see that we are live.
Hmm,
And let me see the audio just to be sure.
hmm. I don't know. We had so many issues last times with the webinars, but
Yeah.
I guess we
Now it's
are.
fine.
I guess we should be
We are
fine to
doing
go.
good.
Yeah.
Yeah.
Yeah. Good.
It's great.
Good. So a new
Okay.
webinar. You took care of everything this time again. So I will be
Yeah.
expectating.
It was just shortly before my vacations to India. I thought, okay, let's work on
Mhm,
variable frequency drive.
mhm.
And with the help of Ragnar, we created a very generic VFD
Yep.
that our users can use who were asking about this device since a long time.
Yeah. I mean,
So we are going to see how this device works and some couple of new features that we have in our workshop.
yeah. I think is one of the most important and most important components, and actually the one
Mhm.
that is taking more time in most of the cases to set up with the PLC, all the
Yeah,
communication between different frequency inverters and the PLCs and so on.
yeah,
So I think this is gonna be just one of a set of probably set of webinars, because we need to dig into this even deeper probably.
yeah.
But it's great that you
S-
you took you have help of Ragnar. He has been working in several projects recently. They're creating different variants of frequency inverters and so on. So you can
mhm.
you will explain us what you have done basically,
Yeah,
and tell me, because I see you can use this device in different ways. So
yeah.
what's all this about?
Okay, just first
Let me see.
to clarify how this idea came from. So I was working on VFDs years ago, not now, it's about 10 years ago.
Hmm.
That time we didn't have much advanced VFD, almost 20 years. So I was working on a VFD from Delta Automation. And
Hmm.
so I modeled this VFD in that similar way how this
Uh-huh.
Delta VFD works. So it's a very simple generic VFD for normal motion control applications,
Hmm.
particularly speed control.
Yeah.
So if you can switch to my screen, I can
Yeah.
show something what's going on.
Yeah. So let's see. Yeah. Okay. Cool.
There you go. So what you see here, let me just hide the panels.
Maybe I can make
Here, where
you widescreen, I think.
if you
Yeah.
can,
Yeah.
oh, that's perfect. Great. So what you see here, we have a conveyor and we have some emitter, which is emitting the boxes, and a remover. So boxes is coming from the right side, going towards the left, and removed here.
Hmm.
So if you notice carefully, there is a change of speed,
Hmm.
specifically when this sensor is getting on.
Uh-huh.
The
Okay.
speed changes. And what you see on the top is a beautiful panel. That's our new feature. We're going to talk about
We're
that in the
gonna
end,
talk about that.
which shows the Node-RED dashboard.
Hmm.
Now we have a streaming of this dashboard within our workspace. So
Cool.
thanks to our developers who are
Yeah.
working on crazy new features. So here, this conveyor is controlled by this VFD. Let me just switch
Hmm.
to another view. Let me see. Control. Oh, my views are not working. Maybe I can jump from here.
Yep.
So that's my VFD.
Hmm.
So here, or can also show you a pin view, which is my saved YouTube.
Hmm.
Oh, then my
Now I
photos on
need to
that.
move you somewhere
Anyways,
else.
it's
Yeah.
okay. I can just zoom in. So we have a tiny display which shows the current speed in meter per second. And on this VFD, we have some status like run, forward, and network. So this is a short form of network. So right now, this VFD is running from PLC.
Hmm.
So the speed control and the operation control, for example, here we have a small PLC. This is our Simumatik generic PLC.
Hmm.
I can control this operation from these two buttons. So now another new feature just right now popped up. Whenever we want to interact with the components, we have to make sure we are on user action mode.
Yeah.
So here we have user action and select mode. So right now I'm on the select
Mm-hmm.
mode. So when I select user action, now I can interact.
Yeah.
So when I press stop, you can see it has some acceleration and deceleration time entered here, and will start to stop. And as soon as it stopped, you can see over here as well, the status changes. So this is just simple on-off
Yeah,
control.
on-off control. Yeah.
But the question is how the signal is moving. So from these two buttons, the signal is physically going to this PLC, like a voltage, to this virtual PLC. And then this PLC is communicating to my TIA portal via S7 protocol. So if I go to my main logic and if I go online, you can see I have a very small block to set and reset an output, which is Q1000.0. And here we have another code for controlling the speed. So PLC is being used to make a logic how VFD should react based on the PLC code. And now this VFD is also having a network mode. We're going to dig into detail later. So this PLC is talking directly to my PLC. So if I show you the communication here, generic frequency inverter, here we have selected, we have mentioned the setup parameter, which is the IP address, rack, and slot. And if I go inside the component, I can show you in the editor, communication driver, in the type, we have S7 protocol. So this is controlled by S7 protocol. And this you can change as well. You can use Modbus, you can use OPC UA, and all the available drivers that we have. So currently, we are just controlling the speed. And another interesting part here, if you see on the set point, this is our display. And I can interact with that. So if I reduce the set point to 0.3, now when the sensor is on, speed will reduce to 0.3.
Okay, so through Node-RED, you are writing in the PLC, and this is the set point that is just while the box is between the sensors.
Yeah, and how Node-RED is talking. So Node-RED flow is here. So Node-RED is communicating to my PLC via S7 communication. So I'm directly writing to the PLC via Node-RED. So this is my database where I send the set point. So what is the speed that we need when the sensor is true? So different technologies are communicating together to make just a very simple example to show motion control. And now I would like to talk about what other things this VFD can do, how you can control it. It's not just about PLC control. If you don't want to use PLC, you can also control just using onboard buttons here or external buttons. So let's just reset the emulation. If you have any questions, you can ask in between.
Yeah. So basically, just summarizing what you show now, you have the PLC and the frequency inverter. Both are configured right now, so they have the option to communicate to the PLC sim that you have programmed with TIA Portal. But on top of that, you have other modes that you are going to show us now, where you can control it without control the speed using just some buttons or electrical inputs and so on. Maybe you can show us the diagram, because I think you showed us before that you have some buttons on the driver itself, those green, red, yellow buttons. But actually, it has some terminals in the lower part, and those are connected somehow.
So I will first talk about the onboard controls. When I go to external controls, then I will talk about the external IOs.
Cool.
So I have also mentioned the description here. So if somebody is using it for the first time, you can check the driver mode. And here it says when it's 0, then it's onboard. If it's 1, it's external. If it's 2, it's external network, for example, PLC. So what happens when you select the VFD here? You have to select the mode. This is the first step. I will go to 0. This is my onboard. So now if I start my VFD, you can see this changed to ONB from network. This is the onboard control. Now it will not listen to the PLC commands. It will listen to these buttons on top. So for example, if I increase the frequency, you can see the knob is moving. It's maybe I hope you can see it a little bit.
No, it's maybe
I
see it now. I see it now.
A small color. So when I press the green button, now I can see my frequency is increasing. Okay, let me just make this 3.0. This is my acceleration, deceleration time. So now I will start one more time. I increase the speed and I start my drive. So now I can start the drive directly from this green button, and you can see the box is moving. And the speed you can change while the drive is running. So the minimum is 0, maximum is 5. And this limit from 0 to 5, one can change from here. Maximum speed is 5 meter per second. And then you can reduce it. So this is the simplest way to use the drive. If you're just controlling some boxes on the conveyor, you don't need any PLC control. You can directly use the drive and control from here.
Can you run it? Can you run it both ways or only forward?
I can run both ways. So here there's a button. This is a yellow button, and I press it. It will stop, decelerate, and then it will go reverse. And you can see the speed in minus. And this you can also see the speed here. Interesting part is sometimes when we have multiple conveyors and we want to have just one VFD as a master VFD and others should follow this VFD. And what you can do is there is a feedback coming out. This is the analog output. You can use this feedback and give it to another VFD. And then if you control one VFD, it will automatically control the others one. So you can make a series connection and control multiple VFD with just one. You can also use external potentiometer, or you can use onboard potentiometer. So you can synchronize different VFDs together. So in onboard control, we only have start, stop, and forward, reverse. Nothing much.
The red one is the stop button, right?
Yeah, this is a stop button. So if I press this, it will stop.
It will stop.
I also had another button here. This is for future. If somebody comes up with an idea that I want to use this button to make a constant speed of 2 meters per second, you can use this button. You just need to program a little bit. So I just keep it open for future if somebody want to use it. So in onboard control, you just have to worry about this driver mode. Just set to 0, set your acceleration, deceleration time, and your maximum speed. That's it. Now, the next mode is when you don't want to go to VFD all the time and press the buttons. You want a remote operation. So in this case, this VFD has some IOs. So if you see in connections, we have AI in. This is analog input. We have forward terminal, ground terminal, reverse terminal. SP1 is set point 1. SP2 is set point 2. And if you see here, they are already connected. So we can see better in a 2D view. So in 2D view, I have a power supply. And here I have my frequency drive. And here we can see the terminals. Forward, reverse, SP1, SP2. So these are already connected to my panel. So it has a push button. Oh, this is a maintain button. And then you have speed buttons and one potentiometer. So potentiometer is basically giving you 0 to 10 volts. So based on this potentiometer signal, we can control the speed from 0 to maximum. And then the speed, the inverter output is connected to the conveyor. So very easy. So you can either do the connection here, or you can do the connection in 3D.
Directly,
So now the question is how to switch to this mode. Very simple. If you read the description, the mode, driver mode 1 was external. So when I select 1, press enter and start the emulation. You just have to make sure you have done the wiring. You will see here the mode is now external. Now, nothing will work here. I can't do anything here. Let's select the user action. So I can't trigger anything because the controls are now external, which means on this panel, I have a potentiometer, which is connected to the drive, and I can increase the speed. Right now, it's not running because the switch is not pressed. So when I press the switch, now it will run in the forward direction. And in the speed, it will follow from here. So I can increase and decrease speed. So this number is basically the percentage how much it has been moved. Yeah, the actual speed you can see here, 2.6, or you can see it on the drive as well. So you can go max as well, however you like. And if I turn it off, it will decelerate and get stopped. Similarly, the second button was reversed. I can move it into reverse action. And now, sometime with external control, you also need to have some set points that you want. So usually in the VFD, there are some terminals that you can use it as a set point. I have used it by default as set point 1, set point 2, but sometimes you also have jog forward, jog reverse. So you can configure it.
Yeah.
So like I said, this is a very generic drive. I have made a very simple one, but for sure anybody can clone it and configure the way they want. So I've used 2 extra terminals. So what happens, these 2 terminals are having parameters like speed 1, speed 2, and speed 3. Speed 1 is 1.0, 2 is 2.0, 3 is 3.0. So when first button is true, it will move to the speed 1.0. So right now this is in reverse. I can bring it forward. So now the speed is 1 meter per second. I can hide this. Maybe I can
you can open
pin the
that.
view.
Yeah, great.
Yeah, now it's 1 meter per second. And if I check the other one, then it's 2. And if I press both, then it will take the third speed, which is 3. Super easy. So 3 set points I can give here.
Okay, so 2 buttons, 2 digital inputs. You can select between no set point using the potentiometer or set point 1, 2, or when you press
and 3.
both the number 3. Okay, cool.
That's 3. It's basically binary to decimal, 0, 1, 2. So when I turn both this off, then it will follow the potentiometer. So different ways to control. We can also imagine this connecting the sensor outputs to this VFD external input. So the thing which I was doing with PLC before, I can do that directly using the sensor signal, giving it to the set point 1 and 2. So this is also possible.
Actually,
or you can also use a relay to latch the signals, things like that. So it's very flexible to use this VFD with external IOs.
Yeah, for simple application, I think it covers a lot of possibilities. Yeah.
Sometimes you have the change of direction with limit switch. This you can also use, and with this limit switch, you can activate the reverse, and it will go in the reverse direction. Then other limit switch will activate the forward, and it will go to the forward direction. So a lot of exercise can be done if it's used in the university for controlling the direction of conveyor. Yeah, so this was the driver mode 1. And the final one is driver mode 2. So you just select the driver mode here. And then you have to take care of the setup parameters, because if, like in the beginning I've shown you, this driver mode is using the type S7 protocol, not PLC sim.
And you don't allow to change that. So from you could do that, but in this case
you could. Right now it's not. So because I have to check which parameters make sense here, because I don't know, you will not use URSIM, for example. So maybe we can make an external input where you can specify which parameters are useful here. So this is actually at the moment it's S7 protocol. And here you can see the set of parameters. I have the IP address and the rack and the slot. So right now I'm not using a real PLC. So I'm using a PLC sim. And this PLC sim is talking to a tiny software which is called Net to PLC sim. So basically, I have an adapter, my Ethernet card, which is communicating now. It is connecting PLC sim in my network adapter. So that's why the IP address which you see here is from my network adapter and the rack and slot. So
you can also use directly the PLC sim driver, but with this one, you can connect to a real CPU or PLC sim or PLC sim advanced. Any of them would work with the S7 protocol. So it's the most flexible, I think.
It's flexible, and also because I wanted to connect Node-RED. And connecting Node-RED to PLC sim is, I think,
it requires the same thing.
Yeah, so I thought, okay, let's use S7 protocol in this case.
Yeah, good.
Okay, so now what's wrong with my mouse? We can't navigate. Let me just refresh the browser.
So maybe we can. What do you want to show now, or?
Now I'm talking about how to configure this, the addressing, starting address.
That's true. That's true.
So once you have the setup parameters ready, the important part is the address, the start address. So this address will define which bits and which words are used to control the drive, to control the speed. So for example, there are only 2 registers we are using. One register is to control the operation, which is start, stop, forward, reverse, This is the two main things we are controlling right now. And another register is for the speed.
Yep.
So when I say starting register 1000, so in this case, if I show you my PLC, here I have all tags. And let me just show you this 1000 and 1002 will be my two input registers. I hope it's big enough to see.
Yep.
And Q1002 and Q1001 is
Yeah.
my output register. So what is happening basically in PLC, I send the speed to QW1002. And this is going to write the speed in my VFD.
Yep.
And when the VFD is working, it sends a feedback in the register IW1002, which I read here. So if I go now online, we can see pretty much. So this is in decimal. The format is not readable, but I can show you that the value will be changing. So now let's split the window. This is a bit tricky with PLC. And I will start to mode 2, it's correct. Now I will start. And now it's running. Speed is getting slow. And there you will see Q1002.
There you have.
There you can see this is the decimal value, which is being changing. And the feedback is coming over here. So this you can see it's changing based on the acceleration and deceleration.
Yep.
And this register, IW1002, in the end, I am reading in the node read. So if I show you node read flow 2, and if I show you the read command, I have this input word 1002. This is my current speed. And this is what I'm giving. I'm changing the format of this numbers, and I'm showing it on the dashboard, which you can see over here, current speed.
And somewhere, I guess you are writing from node read back to the PLC, the set point.
Yes, this is another part. Just wanted to show the variation in the program. So for example, you can see right now speed is 0.3. This is the set point. Now I make a set point to 0.8. So now the speed will be 0.8. So how this is happening? So node read has a slider. So here I have a slider, which is giving me the value from 0 to 2.0. This is the range of the speed I want to set. Actually, it should not be 0, otherwise it will stop. But anyways, so the 0 to 2.0, I convert to the range 0 to 65535. And then, okay, I think this range I have to change. This is when I was testing with 0 to 5. Okay, yeah. So here I have range 0 to 2, and I have a function that from 0 to 5 will be automatically changed to 0 to 65535. So this is an inbuilt function. But my range is only 0 to 2, so it's going to work anyways. And then I'm writing it by a payload to the address set speed. Now this set speed address, what is that? That is my data block, number 1. That is the first register. So if I show you now on my PLC, here I have VFD. This is the DB1, and that's the DB1 I have here. Data block 1. This is the offset 0.0, so its offset is 0, and just 1 register. So whatever slider is doing here is going to write to this value. So if I move now, you can see there the value changes.
So you are not setting the value in the PLC, in the code. You are just hoping someone writes the value. And in this case, it's node read, which is set in the set point.
Yeah, I just have a startup value. You can see startup value is 10,000. If nobody writes any function, it will have a default value.
Yeah, cool.
And this value then I just give here as a set point when the sensor signal is true, and it will change the speed. Now, if somebody who hasn't worked with PLC and Simumatik before, this sensor signals are coming from this sensor via this PLC. So this PLC is reading the signals from the sensors, and then it is sending the signal to the VFD. So these sensors are hardwired to the PLC as well. So if I show maybe in the panel, control PLC. I have these inputs connected in the connection. Here I have input 0, start button, stop button, and then this is a SO1 sensor signal and SO2 another sensor signal. And this PLC is also talking to my TIA Auto by PLC sim. I can also use S7.
Yeah, you could use S7. The same
I could
protocol.
use S7. I switched to S7. I forgot to change here, but it will work anyways.
Yeah.
PLC sim is anyways. So
Yes.
my PLC sim instance is anyways working here.
Yeah. Cool.
So S7 is anyways.
Yeah.
So it's just the diversity of drivers.
Yeah, you're using different options in the same. It's using two different drivers. Yeah. Cool. How about this?
And here is the
Sorry. Yeah, go ahead.
And here was the variable that I mentioned, IB10. So all the inputs that are coming from Simumatik is going to be at the byte 10. So if I show you here, I'm using, I think I didn't mention here, but I can show it in main block. I'm using I10.0. So this 10 has been defined because of this variable.
Yeah.
And for the output is QB10.0. Anyways, we are not using outputs. That's it. That's how PLC, VFD, and Node RAD are interacting for the simple motion control application.
Yeah, it's a cool project. Quite complete. I mean, you're using buttons, the component interaction, and then the PLC as well. So I think it shows different possibilities. And I think it's also a good starting point if someone wants to create a component to replicate whatever real frequency inverter, because it provides the basic. And I agree with you. You usually have a control word, status word, and then you have a set point and the feedback. That's the minimum things. Maybe you may have more parameters or more variables you want to send in when you run the network mode, but this is very basic speed control application.
I mean, for sure, our developers are working hard to create new VFD components that can be integrated directly to technology object or some ABB drives. So I hope we'll come up with that solution very soon and make a webinar to talk about how you can use that as well. But this is a very good beginning point for someone who wants to just control the speed based on some sensor signals or some PLC logic, I would say.
Yeah. So before we leave, because I think it was quick, but I think we don't have much more to say about the frequency inverters. I think we can mention the new features in the release we did this week, because you already have shown some of them. So just so the audience remembers, each time we make a release, we put the comment, we make a new in the app. So maybe you can go back and you can show. So in the homepage we usually show, and maybe we can take it from there and we can explain a little bit the changes. So one of the things you already mentioned is this. We had a lot of requests that when you were emulating, you couldn't select components. So this is something that we finally have developed, and now you can decide to select components both in the editor mode and while you are emulating. So you can click on something and it will be highlighted with this frame kind of thing, and it will also select the component in the panel. So maybe you can show how this works. And it works both in during simulation and not simulation. So
so here's the selection. This is a selection of the buttons and each individual element. So I can't press it because I'm in select mode.
Exactly.
If I go to user action, then I can press it.
So during emulation, we have two modes to interact with the mouse. One is selecting, and the other is the old one, which was just interacting with elements, pressing the buttons or whatever. And we are planning to have a third one. That's why there is an empty option in the menu. And we are not going to tell yet what it's going to be, but it's going to be fun. So there will be a third option. And in the editor mode, we have the previous one. It's just that now we can just select, or we can move, or rotate elements. So that's the difference.
Right.
Sometimes you just want to play or select an element. You don't want the gizmo to appear with the arrows and so on. So you can play with that mode. And then if you want to position something, you can change to the positioning mode, and then you can
That's true.
take that. So
I also like this feature because this allows you to track the object.
Yeah.
I was just checking it before when I start emulating. And let me just reduce the speed a little bit. And now when I select the component, let me see.
Maybe you need to start it, right?
Yeah. And now I can select.
No, you need.
I tried it before.
Yeah, it should work.
Wait a second. I will restart again. User action start. And maybe it's my browser.
Yeah, I don't know. Yeah. We can. It should work.
Yeah.
I don't know.
Now I can't navigate. It's something with my browser.
Oh, okay.
But I think it was working before I checked.
Yeah. So that was one of the things, and the other thing you use it very well in this application is the display.
Oh yeah, this I can tell a little bit.
Yeah.
So let's see. So we have this feature embedded in the component. So I've created a component called display. So if I go inside this component and I go to the S editor, and here you can see you can add a display. So it's not a new component, but it's something that you can integrate to any component.
It's a new puzzle piece.
So once you add this display, you have three different parameters: origin, size, and source. So origin is basically where you want to orient this component, and the size defines the width and the height. So I can also make it 2 by 2, however you like, but based on how you want to show it. This is also in meters, and the source is the main path which you have to give. So right now you can see I've given a path localhost 1800 dashboard page 1. This is actually coming from my dashboard here. So this is the path that I have usually from my Node-RED. So you just copy, or if you have any other path and paste here, it will directly show your dashboard, the live values. And then you can just save it and show it on your screen. And one more part, which was, I think, in the manual they mentioned, which I noticed, that we are only allowed at the moment just to use localhost or 127.0.1.
Yeah, this is if you are using the IP address. You can use public URLs, but you need to make sure that they are compatible with iframe. It's a technology that needs to be available.
Okay. So I think when you use Siemens PLC and when you have this VNC viewer, can you also use that?
Yeah, if it is a web server, you probably can do that. Yeah.
Okay.
Actually, I know that Codesys, the Codesys Web Visu should work because it's also the local host.
Okay. So this was the second new feature that we have. And another interesting feature was about the collision color and the wireframe. So this I can also show maybe a different component. Let's go back. Maybe the conveyor would be a good example. Let's go inside the conveyor and in the editor. So we have now more icons here.
No, I'm going to move you to the side.
Oh, okay.
There you are.
So the first one was thumbnail. We have used that before. Second one was show collision. We know that we are able to see the collision. But now we can also change its color. So right now collision, you can see it's white. You can change the collision color.
That's very useful.
Red. It's green, so it's easily visible where are all the collisions. And if you want to see the boundary of the collision, you can also make a wireframe, and then you can just see how this collision has been
That is super
created.
useful.
Yeah, it's super easy to see collisions. So when you have multiple collisions, it makes sense to show it, to visualize it like this instead of hiding the components which you were doing before.
Actually, I was doing that yesterday. Or yesterday or the day before, because this feature wasn't deployed yet, and it was taking me a bit of time to sync the visual part and the collision, and now this will make things way easier.
Yeah, I think one more feature which we didn't talk in the last webinar was showing the origins.
Yeah, I like
here,
that. Yeah.
I don't have much things to show, but if I open up, bring a robot here, then you can see a different origins. So let's say we take.
Maybe you need to write UR5 or something like that. Something like that.
So UR5. Okay, let's take this one. So there we go. So let's go inside editor. And now in this case, we want to visualize the links origin.
Yeah. And there you have
There
them.
you go.
Yeah.
So it's much easier to understand what's going on.
Yeah. And where you have the joints and and all this stuff.
Yeah. So this is something that people can play around with. Anything that we missed?
No, I think it was all. Yeah. So yeah, I think it was a good start to introduce the frequency inverters. We have been using them in different projects, even the drives and so on. But it was a really good webinar where you show it. And I guess this system will be published. So
I will publish it after now with the webinar.
And the components and so on, so people can play with them and create their own systems with this new component. Yeah. Good.
I will also put the PLC project in the asset, so you can directly start it. Okay.
Great.
And what do you think what we do in the next webinar? Do you have more ideas?
No, actually, I will be on vacation in June, so I don't know. We need to think. We need to think about when will be the next webinar. Yeah.
Okay. Then we will announce that in LinkedIn.
Yeah. What about your vacations? When are you planning?
Oh, it was great. It was.
You were already in vacation. Yeah.
Yeah, I was in India for 2 weeks. It was not a long vacation because you have 2 days just to travel such a long distance, and I have just 12 days left. And time flies when you're with your family. You don't realize how vacations are over. And the next vacation, we don't have any plans yet because we want to spend these summers in our city, which is also very beautiful. People are usually coming here for vacation.
Yeah, I know it's
so
very nice where you live.
Yeah. And but are you coming to Germany as well in this year?
Maybe I can pass by. Maybe I can pass by Germany the way back.
Let me know.
Yeah, I'll let you know.
Yeah, you're more than welcome to visit me. Otherwise, I will be in SPS Nuremberg. There's the biggest fair every time in November. If you want to come, you can also come there.
No, but July I was planning to pass Germany the way back from vacation. So I'm gonna call you. Yeah.
Okay.
Cool.
Great.
Thank you everyone for watching. And thanks, Rashbir. It was a very nice webinar. See you soon.
Thank
bye.
You, see you soon next time. Bye bye.